Hello and welcome. In this video we're going to look at how you can mount volumes onto your Linux system. So we'll look at how we can attach them to our file system on at least a semi-permanent basis. I won't say permanent because you could just as easily come back and unmount them later on. So what this is going to allow us to do is, while continuing with the whole series of videos that I've just done, flexibly manage storage available in our machines. So we can, well, take the storage that we've created in those other videos and attach it and actually make it usable on our machines. Now I kept this as a separate video, one because the other ones were long enough already, but two because what we do here is going to work whether you're using LVM or not. If you have a file system, these steps don't care if it's on an LVM or not. So generally, the file systems that we're going to use on for the rest of the video, I'm just going to say permanent basis. Just understand that you can absolutely undo this later on. Most of our file systems are going to be automatically mounted onto our system, automatically attached when the system boots. If it's something your users need or the system needs to actually do its day-to-day work, you want that attached when the machine boots. Absolutely, you have the capability to only attach something when you need it. We're not really going to look at that here. So for these permanent attachments, we're going to look in a file etcfs tab. And all we do to make a file system be attached to our machine is add an entry to this file. Before we alter this though, I just want to point out, if you are removing an entry for any reason, your best practice, at least initially, is comment out the line rather than deleting it. Double check that your system works without that file system attached, and only after you have double checked that, then you can go back in and delete that commented out line. Which I will demonstrate that in a moment. When we look inside etcfs tab, just a general warning, especially as a beginner, do not alter the entries that are already there. They are built by your system to make it run. Once you know more about what you're doing, potentially you could alter these later on, but for now, do not touch those lines. If you're worried you might have altered one of them, just get back out of this file without saving, go back in and start working again. You're better off having to redo a few minutes worth of work rather than having to try to recover a potentially unrecoverable system. So each line in this file represents one volume that we're going to mount and some details about how it will be attached to our system. And these are the fields that are on that line. The volume, so a unique identifier for this volume that we want to attach to our system. This could be the path to a logical volume or a unique ID that I'll talk about in a moment. The mount point is a directory on that system that we are going to attach this to. So where in our directory structure the files on this drive are going to show up. FS type is the file system type, whatever we formatted it as. So ext4, xfs, swap, exfat, potentially ntfs if you really wanted to, if your system understood how to use it. Options are, well, options of how we're going to mount this. They're a little bit beyond the purview of what I want to cover in this video, so we're going to leave this as just defaults, but you can do things in here like make it read-only. You can control, instead of just root or, well, admin users being able to mount it, you could say any user's able to mount it or unmount it. There's a lot of options. We're not going to worry ourselves with those here. Maybe in the future I make another video just about those details. Backup is whether or not this is going to be automatically backed up by system level backup tools. If you set this to a 1, it is. If you set it to 0, it's not. But again, this is beyond the scope of what I want to cover in this video, so I'm just going to leave these as 0 for now. no, I don't want this backed up. And sequence is the order in which the system should do file system checks when it boots. 0 means don't bother running a file system check on this device. 1 means do this first, 2 would be do this second, 3 would be third, and so on. So let's go to my system, and if we take a look at etc fs tab, there's some comments. Good to know, because this is how we would comment out a line if we didn't want that line actually on our system. I will make this wider so everything actually fits on one line. And each one of these lines is, well, a volume that is attached, where on our system it is attached, the file system type for that volume, the settings for that particular volume, its backup state, and the sequence in which it should be checked if we're doing file system checking. Again, all these volumes here, well, most of these are ones that would exist by default. This archives one is one I've already created just beforehand. You probably won't see that on your system. If I wanted to not have that mount from now on, I would comment this out, save that, reboot my system, make sure everything works normally, and if it does and everything is fine and I'm satisfied I haven't broken anything, then I could go and delete that line if I really wanted to. If I want to add a new entry, I can go in and say, well, the path to the volume, so dev mapper, actually I'm not even going to use dev mapper, I'm going to say dev demo, demo lv. I'm going to attach this at /demo. I will have to create that directory. I think I formatted that as ext4. The defaults are fine for the settings. Don't back this up. Don't file system check this. The spacing on this isn't hugely important as long as there is at least one space between each entry. Some admins do like to take these and then say, oh, that's too far. Sit here and manually, set everything up with tabs. It does make everything line up nicely. The system doesn't really care about that, but it may make it a little easier for you to read it. I start off the video by saying don't alter these lines, and then I turn around and alter these lines. Of course, that's too far. See? That's why I said don't alter these things. And no, the system doesn't care if these are spaces or tabs, but now this is organized in nice, neat columns. It's maybe a little bit easier to read. So I've made my changes, but, oh, actually just as an aside, instead of using the path to the volume, you can also use a UUID for that volume, simply because it is potentially possible for that path to change. Theoretically, it shouldn't. Even if you start plugging in new drives, what was SDA should stay as SDA, so what is SDA1 should always be SDA1, but it's possible that it won't. That if you plug in a new drive, suddenly that new one is SDA, and the next one is the old SDA is now SDB. Shouldn't happen, but I've seen it happen. Although it may have just been a student doing something horribly wrong. Regardless, the UUID on a volume will not change. So you can look up the UUID using the lsblk command and then just paste that into your FSTab entry, and then you can always be certain that that is that volume. This does potentially make it slightly harder to backtrack and find that volume. It means an extra step, but it does mean you never have to worry about that volume changing. So instead of putting in /dev/demo/demo-lv, I could say sudo lsblk. That's not what I want blkid. There we are, and I can find my dev mapper demo-lv there, grab my UUID. It's nice that it even has it in quotes for me there, so I can just copy, go back into FSTab, and instead of putting in that path, I could have just done ctab there, paste in my UUID. So now I can be sure this will always be that logical volume that I created. It will never, unless I delete that logical volume without deleting this entry, this will never break. It just means if I'm coming back later on and trying to figure out, okay, what drive, what volume actually represents demo, I would have to go back through blkid to look up this UUID. Now, for that to mount, I actually need a directory to mount that into. So for this to be part of the hierarchy, it needs to be in a mount point. And all a mount point is a directory. Ideally, it's an empty directory, because any file that's in that directory when we mount something into it becomes unavailable until we unmount that. So I said I was going to put that in demo, so I'm going to sudo mkdir/demo. Just to show what I meant, I'm going to head over there, and I'm going to touch some file. Fine, I will sudo touch some file, because I created that with elevated permissions. So there it is. It's a file. I'm going to get out of this, and I am going to say sudo mount-a. And what this does is tell the system to go into that etc fstab file and mount all of the volumes that are in there, or try to. And if it runs into any errors, it will let me know. No errors. This is a good sign. Now if I go into /demo, there's no files here. If I look at, say, df, probably sudo df, we can see I have this dev mapper demo-lv mounted into /demo. So I have that, what was it, 200 megs worth of space? Or thereabouts. Now attached to my system and usable. But as I mentioned, the file that was in this directory when I mounted stuff here is inaccessible until I always forget that I can't do that. Yeah, it's inaccessible until I unmount this volume. So your mount points should be empty directories. Now I mentioned using mount-a, and this is really important. If you make a change to etc fstab, run the command mount-a. What that's going to do is try to mount all of the volumes that are listed in etc fstab. And if it runs into any errors, for example, you made a typo in the UUID, it's going to let you know right now while you still have a running system and can fix it. If you don't fix this and you reboot your machine and it tries to mount that volume and it can't, you can end up with a system that just will not boot, and then you end up stuck in a recovery shell trying to debug what went wrong. And yeah, I speak from experience on that one. So if let's get out of there, if I VIFS tab again, and I accidentally make a mistake when I'm transcribing my UUID or made a mistake on the path, when I say mount-A, it's going to warn me, hold on, I can't find that volume, or you didn't type defaults, you typed defaults, or whatever. Whatever the error is, it's going to let you know so you can fix it now while you still have a running and runnable machine. So I could go back in, I could go into BLKID and realize, oh, that's a C, not an E. Run my mount-A, no errors. I can be pretty certain this system will reboot. You can also double check if a volume is mounted. I think this is in the slides. If it's in ETCFS tab, you can mount and the path, or if you wanted to unmount it and you have permissions to do so, for example, you're an administrator, you can umount that path, or the directory. Either will work if it's in ETCFS tab. And just note, when you do this, this is temporary. When you reboot the machine, it pays attention to what's in ETCFS tab. So, for example, if I realized, oh no, I had files in /demo that I really need, I could sudo umount /demo, and if I take a look at df-ht again, /demo's not there, I can head over to /demo, because I no longer have anything mounted in it. Hey, there's my file, and I can cp some file to temp. Or I created that as root, so fine, sudo cp. It helps if I type the path correctly. I'm just going to move some file to /tmp. And now I can get rid of this duplicate copy temp thing that I accidentally created. Now my volume is empty, and now, because it's in FS tab, I could just say sudo mount demo. If I didn't have it in FS tab, I would have to give a bunch of the arguments that would go in FS tab on the command line here. I'm not going to deal with that in this lesson. So, what we've looked at in this lesson is how we can mount new volumes onto the machines under our control, and potentially to unmount them if we no longer need them. So now, in combination with everything else we looked at in this chain of lessons with logical volume management and gathering information about our volumes, this allows you to manage the storage that is accessible and attached to your machine. You can reallocate the space as needed, you can add new drives and attach them to your system, and you can use logical volume management to make that management much, much easier. Thank you, and I'll see you in the next video.